Oracle is building OpenAI's data centers, but they can't sell you GPT-5. This is the OpenAI model they can sell you, scoring 4 resumes at once. It's OpenAI's open weight model. They published it free. Anyone can download it. Oracle just hosts it for you, and it's really fast. The AI pipeline reads the posting, compares your resume, and comes back with the gap. No financial crime background, no CAM certification. We run this application on OpenAI's open weight model, the one Oracle will actually sell you. Oracle gives you 2 ways to run a model. Rent a dedicated GPU cluster by the hour, or call it on demand and pay per token. Our application is on demand. Getting there meant testing. At first, 1 model at a time in the playground. That got tedious, so we wrote a script that calls every model in a region and times it. The big OpenAI model ran as fast as the small one, and still wrote a sensible analysis. Chicago came down to one thing. Ashburn doesn't serve the OpenAI models at all. Chicago does, and throttles less under load. So our application runs in that region. Every piece of this is managed. There is no server anywhere in the picture. It starts in the browser, a static single-page app served straight out of object storage. Sign-in is handled by an identity domain, which hands the browser a token. That token gets checked by API gateway on every call before it routes to a small submit function. It does almost no work. It stores your resume in object storage, writes a row to a NoSQL table, and drops a message on the queue. You get back a job marked submitted, and the browser starts pulling. The AI calls take far longer than a web request can wait, so the scoring happens asynchronously. Connector Hub is Oracle's bridge from a queue to compute. It reads the queue and invokes the worker with whatever is waiting. The worker is where all the slow work happens. It fetches the job posting you linked and reads your resume. Then 2 calls to generative AI. One pulls the requirements out of the posting, the other scores a resume against them. The score goes back to the NoSQL table, the analysis to object storage, and the browser, still polling, finally shows the results. Everything is on GitHub, public and ready to clone. Nothing gets built until a pre-flight script checks your tools, your login, and that the model answers. Then run the apply script. Terraform builds the container registry. Docker builds a function image and pushes it to OCIR. Then the functions and the gateway come up together. Under 8 minutes start to finish. The validate script confirms that the deployment is available. Open the application URL and the app loads, ready to sign in. Sign in, add a resume, and submit a few job postings. They score in parallel. The statuses flip from submitted to scoring to scored as each one lands. 2 functions, both active and both running the same image. And there's only 1 image in the registry. 1 container, 2 entry points. Scoring jobs land in the queue and wait there until a worker is free. 4 connectors, all reading that queue. That's 4 jobs scoring at once. The application uses 2 buckets, and they do very different jobs. The public bucket is the web app itself. A private bucket holds your resumes and the reports. And the table is 1 row per job, a partition key, a sort key, and everything else is JSON. There's 1 caveat. Functions scale to 0, so the first request after idle waits for a cold start. The repo is linked below. Clone it, run 1 script, and the whole thing comes up in your own tenancy. And when you're done, the destroy script takes everything down, nothing left running.